Hi, welcome to section 2.9 linear equation. In the first part, we're going to go over on how to clear fractions, then solve linear equation. So let's take a look at our example here. We have negative 3 over 4x minus 3 over 2 equal negative 5 over 6 minus 3 over 8x. So when we take a look at all these fractions, I notice how they all have different denominators. So when it comes to adding and subtracting fractions, we need to look for common denominator. In this section, we're going to be looking for lowest common denominator, also known as LCD. So as I stated before, we're going to focus on our four denominators, which is 4, 3, 6, 8. So I'm going to first list out our four denominators, and then I'm going to look at all the numbers that these four have in common. So first, I'm going to count by 4. So I'm going to have 4, 8, 12, 16, 20, 24, 28, and so on, and I'm going to stop at 52. Now, there is no limit on where you stop. You would just keep going until you find a common number in each of the group. Now there's a reason why I went up to 52, but again, there is no limit on where you have to stop. Next, I'm going to look at the 3 and count by 3. So 3, 6, 9, 12, 15, 18, and so on, and I went up to 48. Again, there's no limit on where you have to stop. Next, I'm going to count by 6. So 6, 12, 18, 24, 30, and so on, up to 54. Next, I'm going to count by 8. So 8, 16, 24, 32, 40, 48, 56, and 64. Now, what we're going to do is examine each of the group and find what common number they have in common. So what I did is I highlighted the common numbers for each of the group. So the first one I highlighted was the 24, and the second number I highlight is the 48. Here we have two choices to use for our lowest common denominator, LCD, which is 24 and 48. Now, according to the term lowest common denominator, we should use the lowest number, which is 24. Now, you do have the option to use 48. The downside of using 48 is that when you're using the 48 as our LCD, you would end up doing more steps for simplifying your answer at the very end. In addition, when using 48, you may end up with using bigger numbers compared to using 24. Again, it's up to you however you want to use. You can use 24, you can use 48 for this example problem, and if you were to simplify, multiply, add, subtract correctly, you should end up with the same answer. However, we're going to stick with 24 because it asks for the lowest common denominator. Again, you have a choice to use 24 or 48, but it would be a lot easier to use the lowest one, in this case 24. So, once you identify the LCD, which is 24, what you're going to do next is you're going to multiply the whole equation by 24. So, I'll put 24 in the front, I put the whole equation in parentheses because that's what I'm going to do. I'm going to multiply the 24 to every parts of the equation. Again, notice how I put the parentheses in front of the equation and behind to demonstrate that I'm going to multiply 24 to every parts of the equation. Now, referring back to when it comes to multiplying fractions, if you multiply by a whole number, in this case 24, you're simply going to multiply to the numerators of the fraction. So repeat, multiplying by 24, we're simply going to multiply to the numerators of each fraction. So here, after I multiply, in the first fraction, I have 3 times 24. In the second fraction, in the numerator, 2 times 24. And the third fraction, in the numerator, 5 times 24. And in the last fraction, in the numerator, 3 times 24. So, the reason I wrote it in this format is when it comes to multiplying, we can actually simplify the fraction. And I repeat, when it comes to multiplying. So that means that we can only do this process, this step, if it's only multiplying. It cannot be if it's adding. It cannot be if it's subtracting. It cannot be if you're dividing. So in the numerator, if we're multiplying, then in this step that we're about to do, we can simplify. And notice how I highlight the 24 in blue to illustrate that we're going to focus on the 24, and in the next part we're going to focus with the denominator. So I circle the 24 and the 4 in the first fraction, the 24 and the 3 in the second fraction, the 24 and the 6 in the third fraction, and the 24 and the 8 in the last fraction. Again, the reason I circle is because now we can start simplifying these fractions, since in the numerator it's multiplying. Now there's a reason I did this, because if you were to multiply, so let's take a look at 5 because that's the highest numerator. So 5 times 24, when you multiply, you're going to end up with 120, which is a triple digit number. So I repeat, that will be a triple digit number. And when it comes to working with triple digit numbers or even double digit numbers, it could be a little bit hard when it comes to simplifying fractions. Hence, which is why we use 24 as our LCD. Had you used 48, that would have been a bigger number than 120, and you would have to work with other big numbers. So in any other numerators, you would have had big numbers in the triple digit range, and then you had to focus on simplifying the fraction. As I mentioned before, in previous section, when it comes to simplifying, if you have an option to simplify and work with smaller number, it would be a lot easier. Versus if you were to multiply, end up with big numbers, you might have a harder task on simplifying with even double digits, triple digits, or even up higher digit numbers. So again, if you have an option like what I'm about to do here, is simplify while you're multiplying so that you can end up with smaller numbers. So what I'm going to do first is I'm going to bring down the negative 3 because we're now messing with the 3 and the negative is in front of the fraction. And again, as I stated before, you can only do this if you're multiplying only. So here in the fraction, 24 divided by 4, when we divide that, it's going to be 6. And I brought down the multiplication sign with the x. Next, I'm going to bring down the minus and the 2 because we're not messing with that. And I'm going to do the same process as I did in the first fraction. I'm going to do 24 divided by 3, which will be 8, and I'm also bringing down the multiplication, so make sure you don't forget that. Next, I'm going to bring down the equal sign with the negative and the 5. And I'm going to do the same process as I did in the first fraction and the second fraction. I'm going to do 24 divided by 6, which is 4. And again, do not forget to bring down your multiplication sign. Then I'm going to bring down the minus with the 3, because I'm not messing with the 3. As I did in the first fraction, the second fraction, and the third fraction, I'm going to divide 24 by 8, because I can simplify that. So 24 divided by 8 will be 3, and I brought down the multiplication with the x. So it's very important you don't forget your variable, but it's also important when you bring down your multiplication sign. So we simplify, and again, this is the main reason why we multiply by the LCD. This is the main reason, is that we were able to convert all the fractions into whole numbers. Once we finish converting the whole numbers and finish the operation, so in this case, the operation is we're going to multiply each part. So in here, I'm doing negative 3 times 6x. In the second part, I'm doing negative 2 times 8. In the third part, I'm doing negative 5 times 4. In the fourth part, I'm going to do negative 3 times 3. So, when we multiply, we have negative 18x from the first part, minus 16 from the second, negative 20 from the third part, and minus 9x from the fourth. So, as I was saying before, by multiplying by del CD, we converted fractions into whole numbers. Now we can start solving this equation as normal with whole numbers. So what I'm going to do first is I'm going to balance the equation by having all the variables on the left side of the equal sign. So I'm going to cancel out minus 9x. So I'm going to add 9x to both sides. So when I add 9x to the left, I'm going to get negative 9x. And on the right, the 9x cancel out. Next, since I have the variable on the left side of the equal sign, I need to cancel out the minus 16. So to cancel out and balance the equation, I'm going to add 16 to both sides. So on the left, the 16 will cancel out, and then on the right of the equal sign, it will be negative 20 plus 16. That's going to end up with negative 4 on the right side, and I brought down negative 9x on the left side. So here we have negative 9x equal to negative 4. So to solve for x, we're going to divide both sides by the number that's in front of x. So in this case, we're going to divide both sides by negative 9. So on the left, when you divide by negative 9, you will have a positive x. And on the right, negative 4 divided by negative 9, when we divide negative with negative, it's going to end up with positive. And we cannot simplify the fraction because there's nothing in common between 4 and 9. So our final answer will be x equals to positive 4 over 9. Now, if you do end up with a bigger numerator than the denominator, leave it as an improper fraction unless we ask you to solve and simplify into a mixed number. So repeat, if you have an improper fraction where the numerator is bigger than the denominator, then you leave it as improper unless we ask to finalize into a mixed number.